Hey guys, how's it going? Today we are going to be solving equations, but a little bit differently than last time. We're going to be finding square roots. So the first thing we might start off with is just a little bit of practice with square root signs. For instance, we know that the square root of a times b, that equals the square root of a times the square root of b. That's a property you need to know, okay? And also something like this, the square root of a over b, that's going to equal the square root of a over the square root of b. Okay, so two things you need to know. Let's just do an example really quick. I have the square root of 4 times 3. Well, that equals, according to this, it's going to be the square root of 4 times the square root of 3. And the square root of 4 is 2, so this equals 2 times the square root of 3. Okay, that's that. All right, let's do another one. If I have something like this, the square root of 36 over 7, okay, well, that equals, according to this, the square root of 36 over the square root of 7. Okay, the square root of 36 is 6 over the square root of 7. And we need to pay close attention to this guy. This guy is not quite finished, okay? We cannot have a radical in the denominator. Okay, that's one thing that you have to be aware of, okay? We can't have a radical in the denominator. All right, so let's try some problems. Simplify. Here, we'll simplify. Here's our first one to simplify, square root of 80, okay? There's a ton of ways you could do this, tons, okay? I like to try to use perfect squares. Like 8 times 10, that's great. It doesn't necessarily give you perfect squares though. 20 times 4, okay? 4 is a perfect square. How about 16 times 5? I think 16 times 5 gives you 80, right? Okay, so watch this. You could break this down a bunch of ways. You can go 16 times 5, which equals the square root of 16 times the square root of 5, which gives you 4 radical 5. Okay, there's a ton of different ways you could do this. Here, you could also do it this way, 80, square root of 80. We could do 20 times 4, right? Okay, well, that's 20 times 4, but that's also, isn't that 20? Isn't that also 4 times 5 times the square root of 4? Okay, so that's going to be the square root of 4 times the square root of 5 times the square root of 4. Okay, well, this is 2, this is the square root of 5, and this is 2, so that still gives us 4 times the square root of 5. Okay, but it just takes a lot longer. So if you could think of ways to find perfect squares hiding in there, you're going to be in a lot better shape. Okay, let's try this one. The square root of, let's try this. The square root of 4 over 5. We'll do this first. The square root of 4 over 81, okay? And that's going to be the square root of 4 over the square root of 81. And that right there, this is 2, and this is 9, okay? It's about to get really loud. My washing machine is going. I hope it doesn't ruin the notes, okay? Let's try this example. The square root of 4 over the square root of 7. Okay, let's try this. Well, that's going to be the square root of 4 over the square root of 7, which equals 2 over the square root of 7. But we can't have a radical in the denominator. So what you do, anytime you have a radical in the denominator, you're going to multiply by the square root of 7, by the square root of 7 over the square root of 7, which is multiplying by 1, okay? And then this equals, in the denominator, square root of 7 times square root of 7 is just 7, because that's really the square root of 49, which is 7. And then in the numerator, we get 2 radical 7, okay? Keep in mind, square root of 7 times square root of 7 is square root of 49, and the square root of 49 is 7. Basically, though, if you just see two of these same things, you get that without the radical, okay? All right, let's do some practice with rationalizing the denominators, part B. Rationalize denominators. part B.